All right, so for the Bohr model practice or Bohr model diagrams practice, for each element, draw the nucleus, including protons and neutrons, correct number of shells as well as electrons. Remember to fill the orbit closest to the nucleus first, but never exceed the number each orbit can hold. Check the periodic table to find out how many electrons each element actually has. Check your notes for guidelines on drawing Bohr models. Here are a few pointers for helping you do this assignment or this practice sheet. Okay, so you can either print this off or you can use Cami. And if you're going to print it off, just take a picture and send that in, attach that for this. And then, of course, I've also got the periodic table here for your reference, for our reference, okay, as we're going through. So our first element here is sodium. So it tells us here, it gives us some pointers. To find the correct number of protons, look at the atomic number. Okay, that's the first thing. Second thing is to find the correct number of neutrons, take the atomic weight, also called the atomic mass, subtract atomic number, and you get the number of neutrons. Number three, to find the correct. Now this one's debatable. You'll eventually get the correct number of electrons if you just fill enough shells that you need it. But this kind of is a way to help yourself along, so I include it. But to find the correct number of shells, look to what period the element is in. Okay, and then finally, to find the correct number of electrons, look at the atomic number. Okay, same as looking at the number of protons. So for sodium, let's start with number one. How many protons does sodium have? Well, sodium is right here. Okay, in the top left corner, we have an 11. Okay, that means that it will have 11 protons. Okay, so we have 11 protons. Now, if we're going to take the atomic weight, okay, so the atomic weight for sodium is 22.990. But we're going to round that, right? As per the instructions you've already been given. We round that number to 23, because 22.9 best rounds to 23. 23 is our atomic mass, okay, our atomic weight. Subtract 11, our atomic number. What do you get? If you got 12, you're correct. Remember, as you're going through this, to pause it and to test yourself, okay? Now, to find the number of shells, well, sodium is in which period? 1, 2, 3. It's in the third period. Remember, the third periods run horizontally, back and forth, right? So it's in the third period. That means there should be three shells. Okay, there we go. We now have 3 shells. The innermost circle is, of course, the nucleus. And to find the correct number of electrons, that's the atomic number. We don't have to go back to this. We can just remember the atomic number is the same number as the number of protons. And so that is 11. Now, when putting them in, there is no official directive on how to place these, but in our class there is, okay? And so what we're going to do is we're going to start at north, okay? Never eat shredded wheat. Okay, so we're start at north, or the top, the right, the bottom, the left. Okay, so always start here. So the first one, and how many can go on the first shell? Right, 2. Okay. Then what we're going to do is we're going to continue to go by ones. Okay, so we go, that's 3, 4, 5, 6, 7, 8, 9, 10, and finally 11. And so that's how you would draw a Bohr model for sodium. Now let's go over to potassium. There's our nucleus. Okay, how many protons for potassium? Let's take a look. Potassium's right here. It has 19. Okay, so we have 19 protons. How many neutrons? Take the atomic mass, okay, or atomic weight, and subtract the atomic number. The atomic mass for this is 39.098, and so we round that to 39. Okay, 39 subtract 19. Okay, you do the math. 20. Now, what period is potassium in? 1, 2, 3, 4. It's in the fourth period. So we're going to need 4 shells. Okay. Now finally, how many electrons am I going to need? Well, I'm going to need 19, right? Because I look at my atomic number, same one as the number of protons. And so that's 19, and so I put them down, 1, 2, 2 on the first shell. Okay. 1, 2, 4, 5, 6, 7, 8, 9, 10. Now you'll notice, and I didn't mention this in this video, but I have before. But notice that the first shell gets 2, the next shell gets 8, the next shell gets 8. Okay. And part of the reason we don't go much beyond 4 is because the rules kind of start to change. But there is 11, 12, 13, 14, 15, 16, 17, 18, and 19. Okay. Yeah, no, they're really beautiful electrons. I get it. Okay. Now the final one that I'm going to do for this instructional video is hydrogen. Okay, we got our nucleus. Now, remember that hydrogen has 1 valence electron. It has 1 electron period, right? And it has 1.008 neutrons. Now, we understand that there is a very small number of well, that should say N. That shouldn't say P. That's a typo. We understand that it's a very small number, but we put down 0. Okay. How many? So 0, 1 minus 1 equals 0. That's why we put the 0. Now the number of shells. Well, what period is it in? It's in period 1, so we're only going to need 1 shell, right? And how many electrons? Same as the number of protons or the atomic number, just 1. Okay. Now that's going to bug me unless I change it. So now it's changed. There we go.